Good evening, everyone. We are presenting our CSE 106 Mini-Project Linear Search and Friendship Graph. Our team members are Abdur Rahman, Ashraful Islam, and Ebadi Punnu, under the guidance of Dr. Nafis Sadiq at East West University. The main objectives of this project are to analyze the time complexity of linear search and confirm its theoretical behavior, to simulate a friendship graph as an undirected graph, to verify the handshaking theorem, to count connected components in the network, and overall to connect theoretical concepts of discrete mathematics with practical validation. For linear search, we followed these steps. First, we generated random arrays of sizes 10,000 up to 50,000. Then for each array, we performed 1,000 random searches. We recorded the average search time in milliseconds. Finally, we plotted the results and added a thread line to see the growth pattern. Here is part 1 of the code. Here is the Python code implementation. The algorithm works by checking each element one by one until the target is found or the array ends. In our experiment, we measured the average search times and plotted them. The results clearly showed a linear relationship between array size and search time, confirming the complexity is indeed O(n) exactly as predicted by theory. Here is part 2 of the graph, part 2 of the code. Linear search results. Our linear search results show that as the array size increases, the search time grows proportionally. This matches the expected time complexity of O(n). So, the experiment successfully validated the theoretical complexity. Next, we move to the friendship graph simulation. Here are the steps. We created undirected graphs with users ranging from 500 to 2500. Friendships were generated randomly with probability 0.005. We calculated each vertex's degree. Then we verified the handshaking theorem, which states that the sum of all the vertex degrees equals twice the number of edges. We counted connected components. Finally, we plotted the results of connected components against the number of users. Here is part 1 of the code for the friendship graph. In this part, we implemented the graph using an adjacency matrix. We used BFS, breadth first search, to count connected components. Our results showed that as the number of users increases, the number of connected components decreases. In other words, larger networks become more connected and unified. This is part 2 of the graph. Sorry, my bad, but part 2 of the code. And this is the graph, the final result. To summarize, the linear search experiment confirmed the empirical time complexity of O(n). The friendship graph simulated verified the handshaking theorem. The connected components analysis showed that larger social networks tend to merge into fewer components, meaning higher connectivity. Overall, this project successfully validated discrete mathematics theory through practical programming and experimentation. Thank you for listening to our presentation.